Hello, science fans. Let's talk about a truly awesome place. It's a place you know very well. It's our home planet Earth. This big, beautiful ball spinning in space is super special. It's not just dirt and water, it's a dynamic, living world. Earth is incredibly old, about 4.5 billion years old. That's a really, really long time. Imagine trying to count that high. You'd be counting for your whole life and then some. Our planet wasn't always the blue and green world we see today. It started out very, very different. It all began with a giant cloud of dust and gas floating out there in the vastness of space. Now, how does a cloud of dust and gas become a planet? One word: gravity. Gravity is this amazing force that pulls things together. Think about when you drop a ball. Gravity pulls it down. Well, out in space, tiny bits of dust and gas started to clump together because of gravity. More and more bits joined the cosmic dance. As these clumps grew bigger, their gravity got stronger, pulling in even more material. This giant cosmic snowball fight of sorts eventually formed a huge, hot, spinning ball of molten rock. This was the baby Earth, a fiery, glowing sphere, nothing like the cool planet we inhabit now. It was a very exciting, very hot beginning. Over millions and millions of years, this super hot baby Earth started to cool down. Imagine a giant pizza fresh out of the oven, slowly losing its heat. As Earth cooled, the heavier materials like iron and nickel sank towards the center. Lighter materials floated towards the top. This process created layers, which we'll talk more about later. Eventually, the very outside layer cooled enough to form a solid crust. This was the first very fragile skin of our planet. The early Earth was a wild place. Volcanoes were erupting everywhere, and meteorites were constantly bombarding the surface. It was a tough neighborhood back then, but it was the start of something amazing. So, Earth is not just a rock, it's a planet with an incredible story, a story of fire, cooling, and constant change. It's a story that is still happening right now. From its fiery birth to the world we see today, Earth has been on an incredible journey. Understanding this journey helps us appreciate our home even more. Science is the key to unlocking these amazing stories of our universe and our place within it. It's a continuous process of discovery, and there's always something new and exciting to learn about our very own planet. So stick around, because we're just getting started on our exploration of Earth. All right, let's take an imaginary trip deep inside our planet. If you could drill a hole all the way through Earth, what would you find? Well, you'd find it's not the same stuff all the way down. Earth is made up of different layers, kind of like a giant gobstopper or a planetary onion. These layers have different thicknesses and are made of different materials. At the very, very center of our planet, deeper than any mine or cave, lies the core. This is the heart of Earth, a place of extreme conditions. It's super hot and under incredible pressure. Getting there for real is impossible with today's technology, but science allows us to explore it with our minds. The core itself has two parts. Let's start with the very, very middle bit, the inner core. This is a solid ball made mostly of iron and nickel. Now, you might think, if it's so hot, why is it solid? That's a great question. The inner core's temperature is estimated to be as hot as the surface of the sun, around 5,200 degrees Celsius, or 9,392 degrees Fahrenheit. But the pressure there is absolutely immense, over 3 million times the pressure at sea level. This incredible pressure squishes the atoms so tightly together that they can't move around like a liquid, so they stay solid. It's a bit like squeezing a snowball really hard. It becomes solid ice. Surrounding the solid inner core is the outer core. This layer is also made of iron and nickel, but guess what? It's liquid. That's right, a giant swirling ocean of molten metal deep beneath our feet. The temperature here is still incredibly high, but the pressure is a little less than in the inner core. This allows the iron and nickel to melt and flow, and this flow is super important. The movement of this liquid metal in the outer core, combined with Earth's rotation, creates something amazing. Earth's magnetic field, it's like a giant electrical generator deep inside our planet, creating a powerful force. So why should we care about a magnetic field generated by a hidden ocean of metal? Well, this magnetic field is like an invisible shield protecting our entire planet. It stretches far out into space, forming the magnetosphere. This shield deflects most of the harmful, charged particles that stream from the sun, called the solar wind. Without this protection, the solar wind could strip away our atmosphere, making life on Earth impossible. It also helps guide animals like birds and sea turtles during migration, and it's why your compass needle points north. That little needle is aligning itself with Earth's mighty life-saving magnetic field. Science is cool, isn't it? Okay, we've explored the super hot core. Now, let's move outwards on our journey inside Earth. Above the outer core lies a very thick layer called the mantle. The mantle is the biggest layer of Earth by volume, making up about 84% of our planet's total volume. Think of it as the meaty part of our planetary fruit if the core is the pit. It's sandwiched between the fiery core below and the thin crust we live on above. This layer is incredibly important because its behavior directly affects what happens on the surface of our world, from the smallest tremor to the grandest mountain range. The mantle is made of rock, but it's not like the hard, brittle rock you might pick up in your backyard. It's mostly solid, but because of the intense heat and pressure, parts of it can flow very, very slowly. Imagine super thick honey or silly putty. This slow movement happens over millions of years. The rock in the mantle is rich in magnesium and iron. Hotter material from deeper in the mantle rises while cooler material sinks. This creates slow-motion convection currents like water boiling in a pot, but on a planetary scale. These currents are a driving force for major changes on Earth's surface. Finally, we reach the outermost layer, the part we know best, the crust. The crust is like the thin skin of an apple compared to the rest of the fruit. It's where we live, build our cities, grow our food and explore. It's the thinnest layer of the Earth, but it's incredibly diverse. There are two main types of crust. Oceanic crust is found under the oceans. It's thinner, denser, and usually made of basalt, a dark volcanic rock. Continental crust is what makes up the land masses, the continents. It's thicker, less dense, and made of many different types of rocks like granite. This is where all our familiar landscapes are found. The crust isn't one solid piece, it's broken up into giant slabs called tectonic plates. These plates float on the slowly moving mantle beneath them. Remember those convection currents in the mantle? They cause these plates to move around, bump into each other, pull apart, or slide past each other. This movement is called plate tectonics, and it's a huge deal. It's responsible for earthquakes, volcanic eruptions, the formation of mountain ranges like the Himalayas, and the creation of deep ocean trenches. So the ground beneath your feet is constantly, slowly but surely on the move. Understanding the mantle and crust helps us understand these powerful geological events. Now let's zoom out from the solid Earth and look at the amazing blanket of gases that surrounds our planet. This is Earth's atmosphere. It's a super important layer, or rather, layers of gases that make life as we know it possible. Without our atmosphere, Earth would be a barren, lifeless rock like the Moon. It gives us air to breathe, protects us from harmful things from space, and helps keep the planet's temperature just right. It's like a giant, invisible shield and life support system all in one. It's held around Earth by gravity, so it doesn't just float away into space. Pretty neat, huh? The atmosphere has different layers, kind of like a cake. The lowest layer, the one we live in and breathe every day, is called the troposphere. It starts at the Earth's surface and goes up to about 7 to 20 kilometers. That's about 4 to 12 miles high. It's thicker at the equator and thinner at the poles. Almost all of Earth's weather, clouds, rain, snow, wind, thunderstorms, happens right here in the troposphere. As you go higher up in the troposphere, the air gets colder. This is why mountaintops are cold and often covered in snow, even in summer. Airplanes usually fly near the top of the troposphere to avoid most of the bumpy weather. Just above the troposphere is the next layer called the stratosphere. The stratosphere extends from the top of the troposphere up to about 50 kilometers or 31 miles above the ground. One really cool thing about the stratosphere is that it gets warmer as you go higher. This is the opposite of the troposphere. Why? Because the stratosphere contains a very special gas called ozone. The ozone layer is a region within the stratosphere that absorbs most of the sun's harmful ultraviolet or UV radiation. This absorption of UV rays heats up this part of the atmosphere. This ozone layer is super critical for protecting us from sunburns and more serious health problems. So these lower layers of the atmosphere, the troposphere and stratosphere, play huge roles in our daily lives. The troposphere gives us the air we breathe and all our weather systems, which are vital for growing food and providing fresh water. The stratosphere, with its amazing ozone layer, acts like a planetary sunscreen, protecting all life on Earth from dangerous solar radiation. Understanding these layers helps us understand weather patterns, climate, and how human activities can affect our precious atmosphere. It's all connected, from the ground we walk on to the air we breathe. Section 5. Reaching for the stars, the upper atmosphere. Let's keep going up, up, up through Earth's atmosphere. Above the stratosphere, we find the mesosphere. The word meso means middle, so this is the middle layer of our atmosphere. It stretches from about 50 kilometers or 31 miles up to around 85 kilometers or 53 miles above Earth's surface. If you thought the top of the troposphere was cold, the mesosphere is even colder. In fact, the very top of the mesosphere is the coldest place in Earth's entire atmosphere. Temperatures can plummet to as low as minus 90 degrees Celsius or minus 130 degrees Fahrenheit. That's colder than anywhere on Earth's surface, even Antarctica. Now, the mesosphere might be super cold and way up high, but it does a very important job for us. This is the layer where most meteors or shooting stars burn up. When small rocks and dust particles from space enter Earth's atmosphere at incredibly high speeds, they rub against the air particles. This friction creates intense heat, causing the meteors to glow brightly and vaporize. So when you see a shooting star and make a wish, you're actually seeing a tiny piece of space rock meeting its fiery end in the mesosphere. Thank you, mesosphere, for protecting us from these cosmic visitors. Without it, many more space rocks would hit the ground. Next up, above the mesosphere, is the thermosphere. Thermo means heat, and this layer lives up to its name. The thermosphere starts at about 85 kilometers or 53 miles and can extend up to 600 kilometers or 372 miles or even more. Temperatures in the thermosphere can soar to 2,000 degrees Celsius or 3,632 degrees Fahrenheit or higher during the day. But here's a tricky thing. Even though the temperature is high, it wouldn't feel hot to you. Why? Because the air is extremely thin. There are very few air molecules, so they can't transfer much heat to an object. The International Space Station, or ISS, orbits Earth in this layer, as do many other satellites. The thermosphere is also where the beautiful auroras happen, the northern lights or aurora borealis and southern lights or aurora australis. These amazing light shows are created when charged particles from the sun, guided by Earth's magnetic field, collide with atoms and molecules in the thermosphere. These collisions excite the atoms, causing them to give off light. And finally, the outermost layer of our atmosphere is the exosphere. Exo means outside. This is where the atmosphere gradually thins out and merges with outer space. There's no clear boundary. Air particles are so far apart here that they can escape Earth's gravity and drift off into space. It's the final frontier of our gaseous envelope. Section 6. The Blue Marble, our vast oceans. Let's dive into another amazing feature of our planet, its vast oceans. When you look at Earth from space, it looks like a beautiful blue marble. Why? Because about 71% of Earth's surface is covered in water, mostly by oceans. This water is essential for life. It's what makes our planet so unique and vibrant in our solar system. The oceans are not just giant puddles, they are dynamic, complex systems teeming with life and playing a crucial role in regulating our planet's climate and weather. They are an integral part of what makes Earth, Earth. Imagine a world without these huge bodies of water. It would be a very different place. We usually talk about 5 major oceans on Earth. There's the Pacific Ocean, which is the biggest and deepest. It's so big it could hold all the continents. Then there's the Atlantic Ocean, the second largest, separating the Americas from Europe and Africa. The Indian Ocean is the third largest, mostly in the southern hemisphere. The Arctic Ocean is the smallest and shallowest, surrounding the North Pole and mostly covered in ice. And more recently, scientists have defined the Southern Ocean, which surrounds Antarctica. All these oceans are connected, forming one huge global ocean. And of course, ocean water is salty. This salt comes from rocks on land eroded over billions of years. Oceans are constantly on the move. They have giant currents, which are like huge rivers flowing within the ocean. Some currents are on the surface, driven by winds. Others are deep underwater, driven by differences in water temperature and saltiness or salinity. These currents play a super important role in distributing heat around the planet. Warm water from the equator moves towards the poles, and cold water from the poles moves towards the equator. This global ocean circulation system, sometimes called the global conveyor belt, helps to moderate climates around the world. Without it, equatorial regions would be much hotter and polar regions much colder. The oceans are incredibly important to us and to all life on Earth. They produce a significant amount of the oxygen we breathe, thanks to tiny plant-like organisms called phytoplankton. They provide food for billions of people in the form of fish and shellfish. They are a source of recreation and inspiration. Oceans also absorb a lot of carbon dioxide from the atmosphere, helping to regulate our climate. There's still so much we don't know about the oceans, especially the deep sea. Exploring the mysterious depths with strange creatures and underwater volcanoes is one of the exciting frontiers of science today. Section 7. Land Ho! Exploring Earth's continents. We've talked about the oceans, now let's set foot on dry land. The solid ground we live on is organized into huge land masses called continents. These are the parts of Earth's crust that rise above the ocean waters. There are 7 continents on our planet, each with its own unique characteristics, climates, landscapes, plants, and animals. Exploring these continents is like taking a journey through incredibly diverse worlds all on one planet. From towering mountains to vast plains and from scorching deserts to icy wildernesses, the continents offer a stunning variety of environments for us to study and appreciate. So what are these 7 continents? Let's name them. Asia is the largest continent by both land area and population. It's home to a huge range of cultures and landscapes, including the highest mountains in the world, the Himalayas. Africa is the second largest, known for its incredible wildlife, vast savannas, and the Sahara Desert, the largest hot desert. North America is where you'll find everything from Arctic tundra in the north to tropical rainforests in the south. South America is famous for the Amazon rainforest, the Andes Mountains, and vibrant cultures. Antarctica is the icy continent at the South Pole, almost entirely covered by a thick ice sheet. It's the coldest, driest, and windiest continent. Europe is often considered a separate continent, though it's physically connected to Asia, forming a landmass called Eurasia. Europe has a long history and diverse cultures packed into a relatively small area. And finally, there's Australia, which is both a country and a continent. It's known for its unique animals like kangaroos and koalas and its vast outback. Each continent boasts incredible geographical features. Think of the Grand Canyon in North America, the Nile River in Africa, the longest river in the world, the Ural Mountains separating Europe and Asia, and the Great Barrier Reef off the coast of Australia. These features tell a story of Earth's geological history. Just like the oceans, continents are not static. They are constantly changing, though usually very, very slowly. Remember those tectonic plates we talked about? Continents are part of these plates. As the plates move, the continents move with them. This is called continental drift. Millions of years ago, all the continents were joined together in one supercontinent called Pangaea. Over time, Pangaea broke apart, and the pieces drifted to their current positions. This movement continues today, shaping our mountains, causing earthquakes, and creating new land. Understanding continents and their features helps us piece together Earth's dynamic past and predict its future. Section 8, Just Right, Earth's perfect spot in the solar system. Our planet Earth isn't just floating randomly in space, it's part of a cosmic neighborhood called the solar system. At the center of our solar system is a star, our Sun. The Sun provides light and heat to all the planets that orbit it. Earth is the 3rd planet from the Sun. Mercury is closer, then Venus, then Earth, then Mars, Jupiter, Saturn, Uranus, and Neptune. Our position in this lineup is incredibly important. It's not too close to the Sun and not too far away. This special location is one of the main reasons why life, as we know it, can exist on our planet. It's all about location, location, location. Scientists often talk about something called the Goldilocks zone or the habitable zone. This is the region around a star where the temperature is just right, not too hot and not too cold for liquid water to exist on a planet's surface. And liquid water is absolutely essential for life as we currently understand it. If Earth were much closer to the Sun, like Venus, it would be incredibly hot. Any water would boil away and the surface would be scorching. Venus has a runaway greenhouse effect, making it the hottest planet in our solar system, even hotter than Mercury. Its atmosphere is thick with carbon dioxide, trapping heat. On the other hand, if Earth were much farther from the Sun like Mars, it would be too cold. Most of its water would be frozen solid as ice. Mars is a cold, desert planet today, though evidence suggests it might have had liquid water in its distant past, so Earth is in that sweet spot. Our distance from the sun means we get enough energy to keep our planet warm enough for liquid water to flow in rivers, fill lakes, and form vast oceans. This allows for the complex chemistry that life depends on. It's a delicate balance, and Earth has maintained it for billions of years, allowing life to evolve and flourish. But it's not just our distance from the sun that makes Earth so special. We also have a relatively large moon, which helps stabilize Earth's axial tilt. This tilt is what gives us our seasons. Without the moon, Earth might wobble much more dramatically, leading to extreme climate shifts that could be bad for life. Our atmosphere, as we've discussed, also plays a crucial role in trapping some heat, the good kind of greenhouse effect, protecting us from harmful radiation and providing gases for life. So it's a combination of factors, our perfect spot, our helpful moon, and our protective atmosphere that make Earth a truly habitable and wonderful home. Section 9, Caring for Our Only Home. Why Earth Science Matters. Wow! We've been on quite a journey exploring Earth from its fiery core to the highest reaches of its atmosphere, across its vast oceans and diverse continents, and even considering its perfect place in the solar system. Our planet is truly an amazing and complex system. It's our home, the only one we've got. It provides us with everything we need to survive and thrive. The air we breathe, the water we drink, the food we eat, and the resources we use to build our societies. Earth is a precious gift, and understanding it is more important than ever. Studying Earth through what we call Earth science or geoscience helps us in so many ways. It allows us to understand natural processes like weather patterns, so we can predict storms and prepare for them. It helps us understand geological hazards like earthquakes and volcanoes, so we can build safer communities and develop early warning systems. Earth science also helps us find and manage important resources like water, minerals, and energy sources in a responsible way. It's all about learning how our planet works so we can live more harmoniously with it. Knowledge is power, and in this case, it's the power to protect ourselves and our planet. Our planet is constantly changing, and human activities are now a major force driving some of those changes. One of the biggest challenges we face today is climate change, caused by the increase of greenhouse gases in our atmosphere, largely from burning fossil fuels. Earth science is crucial for understanding the causes and effects of climate change. It provides the data and models that show us how our climate is changing, how sea levels are rising, and how ecosystems are being affected. This scientific understanding is the first step towards finding solutions and mitigating the impacts. We need science to guide our actions. So why does Earth science matter? It matters because this is our home. It matters because our future depends on how well we understand and care for our planet. Learning about Earth isn't just for scientists in labs, it's for everyone. Every time you recycle, conserve water, learn about where your food comes from, or support efforts to protect nature, you're being an Earth scientist in your own way. We all have a role to play in being good stewards of this incredible blue marble. Let's keep exploring, keep learning, and keep caring for our amazing planet Earth. Because when we protect Earth, we protect ourselves and future generations.